Welcome to solverfy.
So first we want to look at the edge chromatic numbers of Cn. So for those who you need to recall, Cn is going to be something like C3 would be a triangle, C4 would be a square, C5 would be the pentagon, C6 hexagon, so on and so forth. So we noticed before in the previous problem in 21 that the edge chromatic number is equal to the vertex with the highest degree, the highest degree vertex. So we see this one, for example, has, each of these really have two edges connected, or each one has a degree of 2, right? And that is 3 less than the 1, so 3 minus 1 is the 2. Then we see here that 4 has 2 as well. It's always going to be connected to 2. This one's connected to 2. This one's connected to 2. This one's connected to 2. 5, same thing. Connected to 2, connected to 2, 2, 2, 2. And we see that for all of the C graphs, the degree of the vertices will always be 2. So based on that, we know that the edge chromatic number of Cn equals 2. Then let's talk about Wn. So Wn is the wheel, which, so for example, W3 will look something like this. It'll be a triangle. And then in the center will be this right here. And then W4 will be a square. And then in the center will be a vertex connecting all the points. And then W5, we'll do one more example, will be the pentagon. And then in the center will be a vertex connecting all 5 points. So what we see is, once again, the center point is the one that always has the highest degree. Here it has 3, just like all the other ones, but here specifically it has 4, 5. Notice that the highest degree vertex has the same number of edges connected to it as the actual n value itself. So that tells us that the Wn, the edge chromatic number of Wn is just n.